This is lesson 6.6. It is about solving radical equations. We're going to be solving radical equations. When you solve equations of any kind, you use the inverse operation. So, recalling things from previous years, or even this year, the inverse operation for addition is subtraction. The inverse operation for subtraction is addition. The inverse operation for multiplication is division. The inverse operation for division is multiplication. The inverse of x squared is the square root of x. When you square something and then square root it, it undoes the squaring process. The inverse of the square root of x is x squared, because squaring a square root gets rid of the square root. If you had x to the third power, then its inverse would be the cube root of x, and the cube root of x's inverse would be x cubed, because when you do the opposite, then it gets rid of the radical. So we're going to look at some examples that solve equations that have this. The first example is x to the 1/2 power minus 4 equals 1. You might not immediately notice that this is a radical problem, but remember that if you have a power of 1/2, the 1/2 actually means square root. So I'm going to rewrite it as the square root of x minus 4 equals 1. To solve the problem, the first thing I need to do is get the root by itself, so I'm going to add 4 to both sides. So I have the square root of x equals 5. And then the opposite operation of square rooting something is to square it. So I'm going to square both sides. So when you take the square root of x and you square it, it leaves you with x, and 5 squared is 25. So if I take the square root of 25 and I subtract 4, I should get 1. So my solution here is 25. That's what you do if it's a square root. Sometimes you're going to have cube roots with the little 3 right here. So if you have a cube root, the opposite operation of that is to take the problem with the cube and raise it to the third power, because something to the third power is the opposite operation of something to the cube root power. The cube and the cube root cancel each other, and you're left with 2x plus 7. And on the right side, we have 5 to the third power, and if you're in the classroom, you can look on my chart and see that 5 to the third power is 125. Now from here, it's simply solving for x. Subtract 7, so 2x equals 118. Divide by 2. So x is going to equal 5 and 9, so 59. So if I take 2x plus 7 cube rooted and it equals 5, then my x value has to be 59. Okay, what if it's not a square root and it's not a cube root? We're still going to go through the process of getting the radical part by itself, and the first thing I'm going to do is rewrite this problem. X to the 3/2 power is the square root of x to the third power. So first I'm going to subtract 3 from both sides, which gives me the square root of x to the third power equals 8. So now to get rid of the 3 right here, I'm going to do the cube root and the cube root. So the cube and the cube root cancel each other, and I'm left with what's on the inside, which is the square root of x. The cube root of 8 is 2. So now what I have is the square root of x equals 2. How do I get rid of the square root? Well, I square and I square. So squaring the square root leaves me with x, and 2 to the second power is 4. So x to the 3/2 power plus 3 equals 11. That's my problem. If I plug in 4, then that's my solution to this problem. All right, what if I have square roots on both sides? This is much easier than it may look when you first look at it. How do I get rid of the square root? I square it. So if I square one side, I have to square the other side. So on the left side, the square cancels the square root, leaves me with x plus 3. On the right side, the square root and the square are canceled, leaves me with 4x minus 8. And now it's just a regular problem. I'm going to subtract x from both sides. So 3 equals 3x minus 8. Then I'm going to add 8 to both sides. So 11 equals 3x. And then I'm going to divide both sides by 3. So x equals 11 over 3. And that's how you solve radical equations.